Hi everyone. Let's talk about 7B. There are two sections of it. The first one is overlapping events, and the second one is going to be independent versus dependent events. And we're bringing back in some stuff that you've learned in prior lessons and looking at how it applies to probability. Okay, so we're going to start out by looking at a standard deck of 52 playing cards. We know what it is. We've got 52 cards, 4 suits, 13 in each suit. Okay, so this is the basis of what we're going to be looking at. So the definition of non-overlapping events is when two events, you've got event A and event B, and they cannot occur simultaneously. This would be the equivalent of, remember Venn diagrams from a long time ago? This would be the equivalent of having disjoint sets. This is event A, this is the event B. They cannot occur simultaneously. There is no way that it can be part of A and part of B at the same time. So, for example, when you're selecting a card from a deck, the card can either be red or it can be black. It cannot be both. Other examples with decks of cards is one event is selecting a queen or select a king. If you pull one card, it either has to be a queen or a king. It cannot be both. So a card cannot be both a queen and king. The definition of overlapping events is when they can happen simultaneously. This would be, if you're looking at a Venn diagram, I'm going to draw it up here, this would be where you have overlapping. You have event A, you have event B, and then you have something that is both A and B. So, if we're looking at our decks of cards, the event of red card and queen are overlapping because a card can simultaneously be red and it can be a queen. In fact, these would be all the red choices, and these are your queens. So the overlap would be the queen of hearts and the queen of diamonds. Okay. Another example would be if you select a diamond and you select an ace. There is an overlap there. Here are all the diamonds, here are all the aces, and you can have an overlap, the ace of diamonds. Okay. So a card can be, can be a diamond and an ace. Okay. And there are many other examples like that. Okay, so we're going to talk about overlapping events first. So find the probability that a card selected at random can be a queen and a heart. Well, if you want a visual for this, here, of course, are all your hearts. Whoops, I'm not paying attention to what's going on the screen. And here are all your queens. Whoops, except I'm doing the jacks. I need to put my glasses on, I think. Okay, So you've got all of your hearts and all of your queens, and there is an overlap here. And that overlap is the Queen of Hearts. This is your overlap right here. Okay. So, can a single card be a queen and a heart? Yes. So that means that they are overlapping, and for the reason that a card can be a queen and a heart. Okay. All right, now to put that in terms of something that we've done before, let's look at this in terms of a Venn diagram. Here we have all of the queens. Here we have all of the hearts, and the Queen of Hearts is our overlap. This is our overlap. And we would call this event A and this event B in terms of our probability. So the probability that it is going to be a queen and a heart, well, we know there are 52 cards in a deck, and there is one Queen of Hearts. Now, to find the probability that it is either a queen or a heart, well, let's count them all up. Well, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 hearts, and then 14, 15. This one has already been counted, so the probability is going to be, there are 16 possibilities out of the 52 cards. We do not count the overlap twice. Well, and of course there's a formula for it. For two overlapping events, the probability of A or B is you take the probability of the first event, that would be the queens, plus the probability of B, which would be a heart, and then you subtract out. You will basically be counting this twice, so you have to back out the overlap. Okay. So the probability of a queen, if we look at this, there are 4 queens, so the probability of a queen is 4 out of our 52. The probability of a heart is all of these, so the probability of a heart is 13 out of 52. And then our overlap, the queen and the heart, is 1 out of 52. Now remember, when you're adding or subtracting fractions, to add or subtract fractions, they must have the same denominator. And then you just add the numerators. The mathematical rule is if you have A over B plus C over B, your denominator is the same, so the denominator remains B, and you add the numerators of A plus C. So if I apply that here, I have 52, 52, 52. All of my denominators are 52. And I add the numerators. So that's 4 plus 13 minus 1, which is where I get the 16 out of 52. Now, one of the things I want to point out here is in this unit, I do not care if you reduce fractions or not. I want to show you the reduced form of the fractions because depending upon your calculator may give you a reduced fraction. 16 out of 52, each of these is divisible by 4, which means you have 4 over 13. So that means this is also 4 out of 13. And unless otherwise instructed, a fraction is perfect for an answer. Okay, let's go ahead and go on and talk about another situation. Imagine drawing a card from a standard deck of 50 playing cards. Can it simultaneously be a queen and a king? We already said no to that because they are non-overlapping events. It's either a queen or a king or some other card, but it cannot be both. Now notice on the Venn diagram, there is no overlap here. You've got your queens, you've got your kings, it's a disjoint set. This would be event A, this would be event B. Okay, well, what is the probability of selecting a queen? P of Q, well, there are 4 queens out of the 52. What is the probability that it's a king? It's the same thing. There are 4 kings in the 52 cards. Now this is really important. What we're talking about here is the probability of a king or a queen. And this, we go back to our addition formula. Remember the formula for the probability of A or B is the probability of A plus the probability of B. So the probability of a queen or a king is going to be the probability of a Q plus the probability of a K, which is 4 out of 52 plus 4 out of 52, which becomes 8 over 52. You just add those numerators. The probability of a queen and a king is 0. So that's going to be 0 out of 52. So we can put these values into our formula here. So the probability of a queen is 4 out of 52. The probability of a king is 4 out of 52. And the probability of both is 0 out of 52. So again, I just add my numerators. 4 plus 4 minus 0, which gives me 8 out of 52, which is the same thing as 2 out of 13. Oops, and I'm sorry. If they are non-overlapping events, then the formula can be simplified. We don't have to subtract out an overlap because there isn't any. Now, there are 2 ways that you can do this. You can learn both formulas and figure out which one goes with which, or you can always use this and just, if there is an overlap or if it isn't, you're either going to subtract a number or you're going to subtract 0. Either way, it doesn't matter. Okay, so we saw that the probability of a queen is 4 out of 52. A king is 4 out of 52, which becomes 4 plus 4 over 52, which is 8 over 52. Okay, so this is the big thing right here. These are the formulas that you're going to want to know. Now, I'm not big on just memorizing formulas. We will give you these formulas when it comes to a test. However, you're going to have to know how to use them. And quite frankly, this is one of those that if you understand the process, then you will know which formula to use. If you do not understand the process, and that's one of the things we'll talk about when we review, is how to remember what formula goes with what and how you're going to learn those. Okay. Let me quit here and start a new video.